Hey guys, in this class we'll be looking into some basic set operations. So let's get started. First of all, we'll look into two different operations in set and their definitions, and then I'll go explaining about it. So first of all, we'll learn about what a union of two set is. So a union of two set is simply combining both the sets. What does that mean? Well, when you have two different sets, and if you put together both the sets, that set is called the union of the two sets. And then we have intersection of two sets. So intersection of two sets is simply finding where the common area is for both the sets. So let's have a look at an example to understand further about what a union does and what an intersection does. For example, if A is the set of all even numbers and B is the set of all prime numbers, then A union B, this U gives the meaning union, and this upside down U means intersection. So A union B will be the set of all even numbers and prime numbers put together, and A intersection B will be the set of all numbers that are both even number and a prime number. For example, let's take the universal set to be 1, 2, 3, 4, 5, 6, 7, 8, 9. As I've mentioned in the previous videos, we need to define a universal set for every problem we work out, because the universal set tells us where to look. So we're looking at the numbers from 1 to 9, and A is 2, 4, 6, 8. So clearly you see A has taken all the even numbers within the universal set, and B has taken all the prime numbers within the universal set. Then A union B will be 2, 3, 4, 5, 6, 7, 8. It's just combining both the sets together, because that's what union does. Union combines the sets together. So A is all the even number set, B is all the prime number set. So when you put them together, you get both prime and even numbers in the union set. However, if you notice something, we do not write 2 twice. That's because in a set, it is not allowed for an element to repeat itself. So since we have 2 in the set A and 2 in the set B, we might think when you put together you should have 2 twice, or you should have 2 2's basically. But that doesn't happen. An element in a set never repeats itself within the set. So even though there are 2 2's, when you put together, just write it once. And then coming to the intersection part, A intersection B is 2, because that is the only number that is common for both the sets A and B. So the intersection set only takes the number that is common for both set A and set B. Now let's look at how we can show this in a Venn diagram. So this is the Venn diagram that contains all the numbers in the universal set. As you can see, the notation of universal set is right on top there. That means it's just indicating that whatever that is inside the entire triangle belongs to the universal set. So we can only have numbers from 1 to 9 inside this rectangle. And if you see, everything that is inside the circles belong to the union. So for example, this is my set A and this is my set B. So whatever that is inside the circle set A and inside the circle set B entirely belongs to A union B. So if you see, the area that is taken by the set A union B is actually both the circles together. So if I can just shade and show it to you, whatever that belongs inside these entire two circles is the union. If we check the set A union B, it says 2, 3, 4, 5, 6, 7, 8, and all the numbers 2, 3, 4, 5, 6, 7, 8 fall under the green color region that I shaded. So always for a union, when you're trying to figure out the region that belongs to the union, it's basically both the set put together belongs to the union region. So if you think about intersection, it's actually the region where both the circles have overlapped, because it takes the common region, right? The common number. So this region belongs to the intersection of both the sets. And you can see there's only 2 in that overlapping region, because 2 is the number that belongs to both the even number set and the prime number set. In fact, 2 is the only prime number that is also even. So now you clearly understand the region that belongs to the union and the intersection. There is one more operation that we need to look into before we end this video, and that is complement of a set. So what is a complement of a set is basically the opposite of the set. So if you have a look at the definition, it says a complement of a set is everything that is not the set. So in the example, we have defined the universal set as 1, 2, 3, 4, 5, 6, which means we are only looking at these 6 numbers right now. And if A is 1, 3, 4, 5, then A complement is whatever that is not A, which is 2 and 6. So if you look at the universal set, A has taken 1, 3, 4 and 5. So what's left out is 2 and 6. So A complement is going to be 2 and 6. So therefore the complement of a set always depends on what the universal set is. For example, if my universal set, I'll say that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if I said the same thing, so I'm again saying that A is equal to 1, 3, 4, 5. So if A is equals to, or A is the set 1, 3, 4 and 5, what would A complement be? So to find that, let's highlight the ones that belong to A. So 1 belongs to A, 3 belongs to A, 4 belongs to A, 5 belongs to A. So the numbers that don't belong to A are 2, 6, 7, 8, 9. So the A complement for this set is the set 2, 6, 7, 8, 9. So the complement of a set always depends on the universal set that you're looking at. So that is all for this video, guys. Hope you enjoyed this video and learned something new. We'll meet in the next video.